Welcome back. We're going to be talking about patterns in linear functions, what kind of goes along with 4-2 in your textbook. So we're going to be looking at a lot of patterns. And typically when we start off in Algebra 1, they're going to be linear patterns. There's going to be certain things that we're going to be looking at as far as on a graph, in a chart, and also some terminology, some vocabulary. So to start with, there's 4 terms here: independent variable, dependent variable, linear function, and nonlinear function. And you have to understand the difference between all of them. The first one, independent variable. These are simply the inputs or the x values of our function. Okay, what we start with. Think about independent is something that can stand alone. If you're independent, it means you don't need any help from anybody. So that's how independent comes first. A dependent variable are the outputs or the y values. These dependent variables they call them dependent variables because they're dependent on what we start with up here. So the independent and then dependent variables. If we're writing these as an ordered pair, again, x value, y value, it'd be written in this form right here, the x comma y. A linear function is a function whose graph is a non-vertical line. So a line, a straight line, whether it's slanted, down, going up, going down, steep, almost horizontal, even a horizontal, but it cannot be a vertical going up and down. That is not a function. A nonlinear function is a graph that is not a line. Some common ones might look like this. These are called parabolas, and we'll study those at the end of the year. This is a cubic function, and then we have other functions that could look like this kind of like V-looking thing. These are nonlinear. These all have curves in them. There are no curves and no change of direction with a linear function. They will remain constant and consistent with their rate of change. So you want to make sure you have these definitions down. So if you need to, pause the video here and copy these down. Now as we move on, we're going to start identifying and coming up and finding different patterns with our independent, dependent variables, and then eventually writing equations. So the first one we have, the chart we have weight and we have cost. And there's a graph, again, on your, in your notes. It kind of looks like this. And we're going to say these are going up by 50 cents. I'm going to go all the way up to $4. Whoops, $3.50 and $4. It's important that we're able to represent things both graphically and with a chart. So again, this was weight down here, and this was cost. And in our chart, it went 2, 4, 6, 8, 10 in ounces, and the cost was 80 cents, $1.60, $2.40, $3.20, and $4. Now the first thing we need to do is identify what kind of relationship we have. What kind of patterns can we recognize? Well, I'm looking at my weights here. Each time I'm going up by 2. That is a consistent pattern. That's what we're looking for. Again, we're going to be focusing on linear functions. Things are going to make lines. Things are going to be consistent. If we look at the cost, if we notice, it's going up by 80 cents each time. So we have a relationship between these. Okay, for every 2 ounces it goes up, it's going up by 80 cents. So before we look at anything, it's looking like this is a linear pattern. Because these are consistent. Plus 2, plus 2, plus 2, plus 80 cents, plus 80 cents, plus 80 cents. Now when we graph this, we start at 2 and we go up to 80 cents. 4, $1.60. 6, $2.40. 8 and $3.20. And then 10 and $4. And again, I'm just kind of sketching this, but we can see that these lines these points make a line. We can assume that this is a linear function. So, if I'm graphing this, my first question says, is the function a linear or nonlinear function? I think it's a linear. I think it's linear, but I'm going to make sure. The next question is, what is the independent variable? Remember, the independent variable is what we start with. It's right here. Independent variable. So the independent variable is weight. Okay. It's listed down here, and it's our first thing in our chart here. Our dependent variable is our cost. That's the second thing here. Here's your dependent variable. Now, the next question says, how are the two variables related? Well, we could say as the weight goes up 2 ounces, the cost goes up 80 cents. And this is what's tricky. We want to get it on a per unit basis. So instead of going up 2 units, think about this. How do we go from 2 to 80 cents? 4 to $1.60? 6 to $2.40? How are these related? Hopefully, we can see that these are going up by a multiplier each time by 40 cents. Okay, 2 times 40 cents is 80 cents. 4 times 40 cents is $1.60. Our constant increase is 40 cents. So we multiply each time by 40 cents. Now what if we have to have a starting point? When we start counting, we don't just start count anytime. We count at 0. If I want to count how many steps, I'm starting right here, and then I go 1. But I want to know where I'm starting before I even take that first step. So when this is 0, and I'm going to kind of put this in here, what would my cost be? And think about this. This might make some common sense. If something doesn't weigh anything, what does it cost? 0. So we have to think about our starting point too. We're starting at 0. So we want to use this number and this number to come up with our equation. And we're going to come up with our equation. It's always going to be y equals something times x plus something. And this is where the times comes in. It was timesing 0.4. So 0.40 or 0.4x, either one, plus our starting point was 0. I'm using this number and this number to write my equation. And that's how I can relate our two variables. We're going to do one more. So keep that in mind. For every 1 ounce, we're going up 40 cents. And that's where the 40 cents comes from. Hopefully this one might make a little bit more sense to you. Remember the definitions of independent variable and dependent variable. Which one comes first? So in this one we're talking about hamburger buns and how many packs of buns there are. So it says number of packs in our chart and the number of hamburger buns. So here we got, starting off 1, 2, 3, 4, 5. The number of buns, 8, 16, 24, 32, 40. In our chart here, we have packs, and we have hamburger buns. Now I want to go up with the number of packs by ones on my chart, on my graph, and the number of buns, to make it easy, I'm just going to go up by tens. 20, 30, 40. A lot of times you can make these up as long as you fit all of your information there. I'll try to help you with the first part by labeling these in future tests and things like that and assessments. But sometimes you can do whatever makes it easiest for you. So now we want to plot these points here. Again, 1, 8, 2, 16, 3, 24, 4, 32, and then 5 and 40. What does that look like? Again, it looks like it's a linear equation, which it will be, and this is how we're going to prove it. So is the function linear? Yes, it is. It is linear. That's the first question. Letter B, what's an independent variable? What do we start with? What's independent? Here's the number of packs and the packs there. What's a dependent variable? The number of buns. Here's our answers. Here's answer A, B, and C. How are these two related? Again, we see these are going up by ones. Plus 1, plus 1, plus 1, plus 1. Here we're going up by plus 8. So again, there's a constant increase. Again, hopefully you see that relationship. Now, how do we go from 1 to 8, 2 to 16, 3 to 24, 4 to 32, and 5 to 40? We're multiplying by 8. So this is how they're related. Multiply by 8. So in each pack, there are 8 buns. The next question is, well, what if there's no packs? If we're adding 8 going this way, we want to subtract 8 to get back to 0. Now, this isn't always 0. Again, we're just starting to learn this. A lot of times it will be. So again, we're starting at 0. So therefore, our function would be y equals, here's our number 8, times x. If we want to write it as a function, you might see something like this. Whoops, not f of h. We're going to go f of p equals 8p. Something like that. But for now, we're just going to leave it as y equals 8x and leave it like that. Remember, to sum up, independent and dependent variables. Independent comes first, and it's the x values. The dependent variables are the ones that come second, and it's the y values. Look for the relationships, look for the patterns, and that should provide you a good start. See you next time.